This is actually episode 100, so I want to say a massive thank you, Dr. Loeb. You've been on Lex and Joe Rogan, and to come on here is just an absolute honor, so thank you.
Thanks for having me. It's a great pleasure.
So let's start with a big question. Are we alone in the universe? What do you think the chances are that there's another civilization out there exploring the stars right now?
I think it's very presumptuous of us to assume otherwise, that we are alone, that there is nobody else out there. And the reason is simple. First of all, it's numbers. There are hundreds of billions of stars like the sun, and most of them formed billions of years before the sun. So the sun is a late bloomer. And, we are late to the party. We also thought that we are at the center of stage about 500 years ago. Aristotle said that, and for 1,000 years, people believed him because it flatters our ego to think that we are central and important. I can understand that because my daughters, when they were young and knew very little, they thought that they are the center of the world. And when I took them to the kindergarten on the first day, they had a psychological shock. And of course, if you are not searching for anyone, you can be just like Enrico Fermi having lunch and asking, "Where is everybody?" And when a lonely person says that, you say, well, don't think that you are that attractive that they will come to you. If you want to find a partner, you need at least to look through the windows of your home, or perhaps even go to dating sites. And Enrico Fermi didn't build a telescope to look out and search. He said, well, it should be apparent to me if they exist. That's not obvious, because the signals that we produced so far in the 100 years of science and technology are relatively subtle. And, they're making their way out in the form of radio signals. But if nobody is listening exactly with the same kinds of technology that we are using to transmit signals, they might not even notice us. And we were indistinguishable from nature several centuries ago. So to think that they know about us is really presumptuous. To imagine that they care about us is even more than that. I think it's wishful thinking. And I think we should approach it rather than with a mindset of this being a risk, the way that Stephen Hawking argued a decade ago. He said that we should be worried about predators. Instead, I think we should consider it as an opportunity for us to learn, because they are likely to be far more advanced than we are if they reached our doorstep before we reach their doorstep.
So you don't subscribe to the dark forest theory.
No, I think uh, most likely they don't even know that we exist. I mean, definitely if they arrived to our vicinity with a spacecraft, they started the journey long before humans started walking on Earth. That was just a few million years ago, about 1 part in 10,000 of the age of the Milky Way galaxy. So it's really recent that, and moreover, I don't think that predators are really a concern because of the vast distances between stars. It's not as if you can see a prey and bring it home very quickly. I mean, with with chemical rockets, it takes 50,000 years to get to the nearest star, and that's the time that elapsed since the first humans left Africa. So, roughly speaking, so just think about noticing a prey and taking 100,000 years to bring it back home. That doesn't sound like a good idea. There are other reasons to venture to interstellar space, and we are already noticing them. For example, there are existential threats. There could be an asteroid that will hit the Earth. And 66 million years ago, the dinosaurs didn't look up. They didn't have telescopes. They didn't realize that a rock the size of Manhattan Island is approaching Earth. And so they were quite arrogant and they ate the grass, but then were completely decimated, those non-avian dinosaurs. So, that is one risk, existential risk, that could convince us to move away from this planet instead of worrying about being hit at one location and losing everything we care about. Another is obviously what we are doing in terms of changing the face of the planet. I mean, industrial pollution, in global warming, and finally the sun. Within 1 billion years, the sun will boil off all the oceans because it will brighten up, and we will have to go somewhere else because the Earth would become a desert, just like Mars. And that is just 20% of the lifespan of Earth. So we are sort of living at the last fifth of the history of life on Earth, life as we know it. So there are many reasons for a civilization that develops technologies that allow it to go out to leave their planet. If you think about it, the Earth is just a rock that was left over from the formation of the sun, and it's not the most appealing platform that you want to be on. If you can build your own platform and put it in space, you can adjust your distance from the sun. If it brightens up, you move farther away from the furnace. You can even build your own nuclear reactor, so you don't need to rely on a star. You can go places. There is much more real estate away from Earth than on Earth. I mean, the universe is vast, and we keep thinking about, zero-sum games on Earth. All the wars. Currently, there are two wars going on for territories on the surface of this rock. But there is so much more territory out there, and I'm not hopeful that humans will change their priorities. We put most of our money into conflicts right now, $2.4 trillion on military budgets worldwide. And, John Lennon thought that by singing the words, "Imagine all the people living in peace," something will change. But I'm not that naive. I think we need shock therapy. We need to see another civilization that did much better than we do by venturing into space, and that could inspire us to do the same.
Right. Okay, so then let's talk about getting on those alien dating websites or trying to get that kindergarten shock. A lot of people refer to the Drake equation, a very famous equation, a very famous framework of thinking. The updated version, I think, is the Seeger equation by Dr. Sarah Seeger. So that the Drake equation tries to estimate the number of civilizations out there. It gives a variety of variables. You multiply them, and you get something like, 1 million or so civilizations in this galaxy alone. So, do you still think that this is a good way to frame the question, a good way to even think about the question, or does it leave too much up to chance?
No, I think, well, the Drake equation was formulated to estimate whether we have a chance of detecting a radio signal, which was what Frank Drake had in mind when humans developed radio communication on Earth. And the equation is very different. If instead of waiting for a phone call at home, you look for packages in our backyard, that's a very different method of detecting technological signatures, because physical objects like a spacecraft or space trash that could be our treasure, by the way, their trash is our treasure. The equation that describes that, and I wrote this equation, has to do with the number of such objects per unit volume that are within the detection distance that we can see. And so the chance of you seeing something like a package is how many such packages exist within the region that you can detect them. And that is a very different equation. It has to do with, it doesn't have any term associated with the lifespan of a technological civilization, the way that the Drake equation has. And there it's relevant because you want to detect a signal when you are listening, when you are waiting, and the duration of transmission matters. If they transmit it for a short time, the chance of you noticing it is small if you are monitoring the sky for a short time interval. So, however, physical objects accumulate over time. They don't escape from the Milky Way galaxy like the way that radio signals do. And so they are just like plastics in the ocean. I mean, the rockets that we launched have a speed that is well below by a factor of 10, lower than the escape speed from the Milky Way galaxy. So they keep accumulating over time, over billions of years. All the chemical rockets launched over the history of the Milky Way are still within the Milky Way. And they are just accumulating, and there is a certain number of them per unit volume, that's a very different consideration than the Drake equation formulates. And I actually wrote this equation in trying to figure out, given different telescopes, how many gadgets are we expecting to detect depending on how many were launched by any civilization. Another thing to keep in mind is that even a single civilization that may have existed in the past in the Milky Way galaxy could have produced self-replicating probes. That's very different. I mean, you can't have a radio signal that produces a radio signal that produces two radio signals that produces two radios, such that you have a large number of radio signals. You can't do that. However, you can produce a 3D printer equipped with AI, artificial intelligence, that would go places and use the raw materials to produce more of the same. The way to think of it is just like dandelion seeds, seeds of the dandelion flower. It produces them, spreads them in the wind. It's not connected to any of them with an umbilical cord. They are carried by the wind, they land on a fertile ground, and they reproduce the flower. And they can reproduce many flowers because each flower produces many seeds. And so if you imagine exactly that approach, an approach taken by nature, but applying it to technology, a single civilization sending just one or a few self-replicating probes that are effective, those would multiply like crazy. Within 1 billion years, they would fill up the Milky Way galaxy, because that's the time it takes to cross the Milky Way galaxy, roughly speaking. So by them going places and duplicating themselves, you can fill up the entire Milky Way galaxy with probes. And that doesn't require more than just one advanced civilization that can produce such self-replicating probes. So there is this is a very different scenario than the one contemplated by Drake. And the Drake equation is completely irrelevant in this context, because one civilization that produces self-replicating probes fill up the Milky Way. And the only question is how many such gadgets exist within a certain distance that we can see them by their reflection of sunlight or by the light that they produce. Artificial light that they produce. So that's a very different situation.
It seems like we have to talk about the Great Filter, because that is something that, a lot of people, when they're talking about extraterrestrial life, UFOs, aliens, all of these things, it comes up. We don't really know whether we're in front of or behind the Great Filter. So just as the question, what is the Great Filter? And do you think we're in front of it, or could we potentially be behind it?
Yeah, that's an excellent question. The Great Filter is a potential event or catastrophe that could determine the lifespan of our technological civilization. Now, if you are selecting a random day in your life, okay, it's most likely to be somewhere around the middle of your life. I mean, it's highly unlikely that you will choose the first day of your life as a baby just born, or the last day of your life when you're almost dead. Most likely it will be somewhere in the middle, simply because there are many more days around the middle than the first day or the last day. So by the same argument, you might say, okay, we have 1 century of modern science and technology. How much longer will we survive? And if the argument holds, we have 1 to 2 centuries left, because right now we're in the middle of our lifespan. That's sort of the typical time you will find yourself in. That's not very optimistic. And some people say, indeed, we are developing, artificial intelligence that could endanger the future of humanity. We are changing the climate on this planet that could also bring a catastrophe. And through social media and polarization, we're getting much more aggressive with each other. So it's possible that we will not last very long. And that's why we need at least to send some of us away from Earth so that they will carry the torch. I mean, this could be AI systems. I don't mind sending technological kids that represent us and reproduce the conditions on Earth. But there is some urgency to leaving our planet, because the only civilizations that would survive long term are those that are able to avoid a catastrophe And the way to avoid it is not to be just in one place at the same time, to be in multiple places so that a single point catastrophe does not destroy the civilization. And you can think of many civilizations that predated us around other stars, because there are hundreds of billions of stars like the sun, with a significant fraction of them, maybe 10% or so, that have a planet like the Earth, roughly at the same separation. So what happened to those civilizations? Well, before the catastrophe that destroyed them, there must have been a lot of tragedies out there, because just imagine those stars that already aged more than the sun, and they burned up the planet next to them. And so the civilization either left in an exodus or perished on that planet, and we never heard of them, and we will never know about them, because right now the surface is burned, that there is nothing left there. If I apply Darwin's survival of the fittest, the natural selection criteria to interstellar space, I would argue that the fittest civilizations, those that survive the longest, know how to adapt to changing circumstances, know how to avoid a catastrophe on their birthplace, on their planet. And it remains to be seen whether we will leave our planet before we destroy it. I certainly hope so.
I want to take a kind of aside from this line of questioning. We've mentioned going off planet, possibly creating artificial habitats, rotating around the sun, etc. Do you think that if we do kind of go to Mars or create these artificial habitats, it's kind of like an escapist philosophy where people want to leave this planet and say, well, we failed here, but we'll do better next time, and kind of just want to forget what we did here? I know it's kind of a parallel question to what we're talking about, but I do feel like a lot of people look at what Elon Musk is doing and our wants and needs to go to Mars and then expand into the solar system as kind of like a hesitation or an ignorance to what we did on this planet.
Yeah, so, well, first we need to remember that we might be all Martians, because it's possible that Mars cooled first. It's a smaller object, so it provided the conditions for life. It had liquid water on the surface and cooled earlier than Earth, and therefore had the first living organisms in the solar system. And it's possible that life, Martian life, was delivered by rocks to Earth, because there was a large, heavy bombardment of Mars, and that chipped off rocks from the surface. And we know of one rock that was analyzed about 40 years ago that was not heated by more than 40 degrees Celsius. So any microbes inside of it could have survived the journey. And in that case, the ambition of Elon, I mean, there were microbes that already accomplished what Elon Musk is trying to accomplish. And they did it billions of years ago. So it's not really such a major feat. Perhaps life was brought to Earth from Mars. And then, of course, Mars lost its atmosphere 2 billion years ago. And as a result, it lost its liquid water on the surface, and there is no life on it. But it may have been thriving with life the way Earth was before that. Now Mars is just another rock, okay, that nature gives us, which happens to be smaller in mass than the Earth, and that's probably why it lost its atmosphere. It didn't have a strong surface gravity to hold on to its atmosphere. But it's sort of like looking at in the jungle, looking at one tree versus another and saying the other tree is closer to a set of bananas that could feed us for a while, and so just choosing that tree instead of this tree. But both of them are what nature gave us. Mars and Earth are what nature produced without us in mind. It's just rocks left over from the formation process of the solar system. So why should we really rely on those natural rocks? Why don't we aspire to build a city? We don't live, both you and I, right now in the jungle, right? Why? Because in a city, you can control your quality of life. You can live much longer. You have everything you need around you. And we can do the same thing in space. Instead of saying, oh, here is another rock that we can move to, like saying, here is another tree that we can jump to, let's just build our own space platform where humans can live long term and have the conditions they need, where they have the power, they have everything, they have the protection. By the way, if we go to Mars, we will need to live in caves because the surface is steadily bombarded by energetic particles, cosmic rays, that can destroy the human body within a few years. Moreover, the surface temperature changes by hundreds of degrees between day and night. It's very hazardous. So it will be a bit ironic. We started in prehistoric caves, and we are going to Mars to live in caves. My interest is to find out whether, if we ever go to caves in Mars, whether there are prehistoric paintings on the walls. Maybe there were some intelligent beings out there that we don't know about because we never went into these caves. But coming back to your question of whether it's escapism, I think of it more as survival. Okay, so the issue is, how can we avoid us dying, all of us dying, and everything we cherish disappearing? How can we avoid that? And it seems to me inevitable that we will need to leave this planet because the conditions will just be unbearable for a variety of reasons in the long term. So we need to start planning for that. And, of course, if we use AI to develop modern medicine that increases our lifespan, if we become immortal, that would allow us to go on very long trips. The question is how to protect the human body in long journeys and so forth. And we might venture to space also with AI systems. I don't have an issue with that.
So, other than Mars, it seems like we can go to in Jupiter, Europa, Io, Ganymede, Callisto, I believe. Saturn is Titan. Do you think that any of these moons could house life? Would it be likely, or is it just kind of like a hopeful question? And also, what's your favorite moon?
Oh, yeah. My favorite moon is Titan
Likewise.
because it's the only other body in the solar system that has liquids on its surface other than Earth. Earth has water. Titan has methane and ethane. It has a surface temperature that is 3 times smaller relative to absolute zero compared to Earth. It's about 92 degrees above absolute zero, where Earth is room temperature is about 3 times more. So the reason I want to visit Titan is I want to go fishing there. I want to check if there is any fish swimming in those oceans and lakes and rivers. And of course, if I catch any fish, I will not eat it because it's not life as we know it. But it will be remarkable because it would represent life as we don't know it. We don't know if life exists in any other liquid than water. Now, there will be the Europa Clipper mission that is about to get launched very soon. And it will get there by 2030 and will basically go around Europa, the moon of Jupiter, because we know that under the surface ice, which goes 30 kilometers deep, there is a liquid ocean. And through the cracks in the ice, we see plumes of water vapor coming out. And the interesting question is, are there any fish or any living organisms in the ocean? And one way to find out is to see if the ingredients or the nutrients necessary for life as we know it are coming out in these geysers. And by flying through them and taking pictures of the surface, the Europa Clipper will teach us more about what's happening there. And that could be also an environment where life exists, similarly to Enceladus, another moon that has geysers coming from the cracks in the ice. And then, of course, there is Venus, where phosphine was detected, but it's not clear whether it's indicative, whether the detection is real, that it's still being debated, and whether the it's indicative of life in the clouds there, because obviously on the surface it's too hot over there for life to exist. Frankly, my interest is not so much in microbes. I mean, microbes may be everywhere. And as much as it will be thrilling to find microbes on another site, and it will not threaten our ego because we can still claim that we are the smartest, I think it's much more exciting to discover intelligent life. And it would be much more conclusive, because if we find a gadget with buttons on it at the bottom of the Pacific Ocean that was not produced by humans, that the question will be, should we press a button? And what can we learn with the way it operates? Is it Chat GPT 100? What kind of new technology or science can we learn from it that represents our future? And I think that is far more exciting by all orders of magnitude. In fact, I would give all the money in the world and all the honors and credits and everything that people aspire to get, everything, just knowing whether there is an intelligent partner out there, because it will change everything for our future. Just that knowledge, very different from knowing that there are microbes elsewhere.
So let's talk about a possible gadget that was not in the Pacific Ocean but was racing through our solar system. Oumuamua was this super mysterious object, one that you were very famous for talking about. Some people might think it's a piece of alien tech. As you were saying, another civilization's trash is another civilization's treasure. What made Oumuamua so different from anything we had seen before?
Yeah, so it was the size of a football field, and the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And the best fit to the variation of brightness was that of a flat object that is disk-like, which is very unusual. I mean, we haven't seen an object changing its brightness by so much that is naturally made, like a rock in the solar system before. And in addition to that, the object showed an excess push away from the sun without any evidence for either dust or gas around it that could give it the rocket effect, the push as a result of evaporation. And so I suggested that it's just sunlight that is pushing it. But for that, the object had to be very thin and like a membrane. And I suggested maybe it's a piece, torn off the surface of a bigger object, or maybe it's a broken piece of a megastructure like a Dyson sphere. At any event, nature doesn't make such thin objects that can be pushed by reflecting sunlight. And actually, just almost 2 years later, there was another object discovered by the same telescope in Hawaii. It was given the name 2020 SO. And it was realized a few weeks later that this object is, in fact, a rocket booster that was launched by NASA. And that demonstrated my point that this rocket booster was hollow. It had thin walls and was pushed by reflecting sunlight because it had a large surface area for its mass. So I said, well, I rest my case. Here is an example where we know it's technological because we produced it. But there was no paper published on 2020 SO. The astronomers, just ignored it and moved on to argue that the object that was discovered in October 2017 was a rock of a type that we've never seen before. And that came in various flavors, like the argument that maybe it's a hydrogen iceberg. We've never seen a hydrogen iceberg. It can only be produced under very different conditions than we find in the solar system. It must be some molecular clouds. We don't know if they produce things like that. We've never seen an object of this nature. And in fact, hydrogen icebergs would be evaporated long before they arrive to us. And I showed that in a paper, and the authors agreed to that. So then another team suggested it's a nitrogen iceberg. And we showed that there is not enough solid nitrogen to account for nitrogen icebergs of large enough abundance that we would see one of them over the period that we were monitoring the sky. And then another team suggested, well, maybe it's a dust bunny, collection of dust particles that are very fluffy, and because of that, they can be easily pushed by reflecting sunlight. And the problem is that when such a cloud comes close to the sun, it will get heated to hundreds of degrees and may not maintain its integrity. And so there is this natural tendency of quote unquote experts to argue that it's something natural, but of a type that we've never seen before. And rather than say, okay, well, in addition, let's consider the possibility that it's a weird object that was technologically produced. No, they don't want that on the table until it's 100% clear that it is, that we can see the screws and bolts on it, or that we can demonstrate. But my point is, in order to obtain more data, to seek more data, we should stay curious rather than just saying it's natural and moving on, because that's exactly the argument that led to very limited data that we collected on Oumuamua. Everyone said it's a rock, it's an asteroid. And then we saw the fact that it's pushed. So then everyone said it's a comet, but you just cannot see the tail of the comet. And to me, it sounded just like Hans Christian Andersen's tale, where I'm the kid saying the emperor has no clothes, because you don't see the clothes. In this case, the cometary tail of this comet, and comets are defined by a cometary tail. And everyone else, the adults in the room, were saying, "Oh no! The emperor does have clothes, but they are invisible." So this is a comet of an invisible type. And to me, it sounds disingenuous to ridicule and push back against other potential explanations. And all I'm arguing for is getting as much data as possible on the next one. And together with my students and postdocs, we'll try to analyze data from the Rubin Observatory that will come in 2025, that will potentially discover new objects like Oumuamua. I call them Oumuamua's cousins. In fact, today I'm submitting a proposal to the Webb telescope together with an undergraduate student at Harvard, Sri Ram Elango, that basically asks for observing time on the Webb telescope to look at any such objects that might be discovered by the Rubin Observatory, because if you look at them from Earth and from the location of the Webb telescope, which is 1,000,000 miles away, it's just like looking at an object with two eyes. The reason we have two eyes is that we can assess the distance of a predator. That allowed us to survive. And so with a Webb telescope and a ground-based telescope, we can figure out the distance of an Oumuamua cousin and track the orbit, the trajectory very precisely, and figure out whether there is any propulsion or any acceleration that is not gravitational, that is acting on this object.
I was going to ask, if we did get an Oumuamua round two or a rematch or something where a similar kind of object was passing through the solar system, what would you do differently? Especially now that you've been on Lex, you've been on Joe, you have a massive community around you, people are very interested in your work. I was wondering how we could utilize the aspect of community to engage people and also to get as many eyes on this as possible, as many different opinions. One of the things we'll ask about UFOs in a second, but the UFO community, they're very, very vigilant in the sense that they don't take BS. They're always trying to prove it wrong with respect. They want it to be real so badly, but they also don't want to be delusional in that way. So how could we use, the massive community that you've built, along with all of the technologies that we use, so that when Oumuamua's cousins and maybe another family's cousins and such do come passing through, we can take advantage of that and get more answers.
Yeah, thank you. I should mention also that very recently I was on the Sean Ryan show that was aired just a few days ago and got a few million views. And there will be a Netflix documentary coming out by the end of 2025. They came with me to the expedition to the Pacific Ocean to look for the materials of the first interstellar meteor. And That should be, again, a community builder kind of public outreach. I'm also engaged in a few more endeavors that I cannot mention right now, but you will know about within the coming months. And so I completely agree with you that the goal should be to get as much data as possible. I mean, it's just like in politics, the extremes are popular. You have in politics, you have the extreme left and the extreme right, and both of them make statements that are not particularly appealing, that do not make much sense. But there aren't many people taking the middle of the road that sort of saying to both sides that you're missing aspects of the issue. And therefore, I'm very pessimistic. If we were to train AI systems on human content, they will probably get polarized very quickly because there is very little content that is based on common sense in the middle of the road. Most of the content that you find is going to the extremes. And while you might say, okay, that's in politics, perhaps in science it could be better. No, not so, because science is supposed to be based on evidence, okay? But that, collecting the evidence is a lot of work. You have to build the instruments, you have to collect the materials or data, and then you have to analyze it, and then you have to publish it in a peer-reviewed journal. And all of these steps take a long time. It took us a year to publish our results from the Pacific Ocean expedition in a peer-reviewed journal. And guess what? During that year, there were lots of people expressing opinions about that we went to the wrong place, that you can't believe the US government that provided the initial data, that what we recovered is coal ash, that in fact, we went to the wrong place. All kinds of statements were publicized by people who expressed their opinions. They didn't have access to the materials. We had to do the difficult work. And so that demonstrates to you that it's very easy to voice an opinion, much easier than to do the work in order to figure out what is really out there, and that's the work of science. Science is supposed to be based on evidence. It's just like a detective story. And so how do you make progress in science? By collecting more data. If a detective has more evidence from the crime scene, it's easier to figure out who the criminal is. That's obvious, and the same is true in science. But what you find in the context, for example, of, you mentioned UFOs or UAPs or anything to do with objects near Earth that may represent an extraterrestrial technological civilization, is that you have believers. Those are people who already know the answer. They believe in it, sort of like religion. They have a belief system that contains this notion that we are being visited. And they don't need the evidence. They know and so they use the evidence as a tool to substantiate what they already know, okay? And then you have skeptics. These are people that will debunk anything they hear about the subject. And those skeptics, they are extremists of the opposite type, and they would ridicule the act of searching for the evidence, which is what science is doing. And they will claim they're doing it for the sake of protecting science. So you have people who claim that they are protecting science. These are usually science popularizers. They are not practicing science. They are just bloggers or journalists that are reporting about science, and they will ridicule the collection of evidence, the analysis of data related to anomalous objects in the sky. Why would they ridicule? After all, this is the way science should be done. They should cheer for that. They should say, well, let's remain agnostic until more data is collected, and then we can talk about the data that is collected. But the same, in a microcosm, the same phenomena was encountered with the expedition that I led, because we had the materials. So why didn't some scientists just say, let's wait and see when they publish their results in a scientific paper and then comment on it? Why did they have to say it's coal ash, they went to the wrong place, we don't believe the US government, forget about it, and attack me personally while we were doing the analysis? Why did they need to do that? That's an urge of skeptics to kill the flower when it's just rising above the grass level. Because if you step on that flower and it doesn't rise above the grass level, then you can say, well, there is nothing above the grass level. It's all grass. And by killing it, you are eliminating any risk that you might have been wrong. So skeptics enjoy not being wrong by killing any flower that tries to rise above the grass level. And that's very bad for science because science is supposed to be driven by curiosity. So if you see something anomalous, it may be anomalous because it's really a new knowledge that we've never imagined before. Like in this case, it could be a technological signature from outside of this earth. Or it may not be, it may be natural. Okay, so how do we figure it out? Not by ridiculing the scientists who are trying to collect the data. You don't do that. That means that you are against science. And that's what bothers me, that those people who pretend to protect science are anti-science. Just keep that in mind. Bloggers and journalists who are not practicing science should not be in the job of ridiculing the scientific work of real scientists who are tenured professors like myself. I mean, they are not supposed to tell me what I should do when I go and collect evidence. And guess what? When we came up with the findings and published them, and they were accepted for publication, and I wrote to the same journalists and the same critics, I said, here is the scientific paper with all the results. Did the journalists report about it? No, they said, thank you. But they reported about the controversy that preceded that because some people made claims that are not substantiated. They didn't have access to the materials that we had. So something is wrong in the way that the discussion is occurring in this context where you have, just like in political discourses, you have skeptics and believers on this item, but both of them are not doing the hard work of science, which is middle of the road, collecting data. In the context of UAPs, I should say I'm leading the Galileo project. We built an observatory at Harvard University, and we are in 2 weeks, about to release a scientific paper that describes the first results. Over the past few months, we collected data on 500,000 objects, and we analyzed them with machine learning, artificial intelligence. Again, it's hard work, took a long time, but we are doing the scientific work. We're asking, is there anything in the sky? The US government, the US intelligence agencies are talking about these things. And, just over the past few days, there were news reports about objects that the US government is unable to figure out. These are probably drones that are hovering around sensitive areas, and lots of them, and they behave in ways that the US government doesn't understand. So obviously that could be a matter of national intelligence if those are human-made. But if any of them is not human-made, scientists like myself should examine them because we need to figure out if they came from another star, so that's what we are doing in the Galileo project. And in addition to the observatory at Harvard, we are building 2 other observatories in 2 locations, one in Pennsylvania and the second one in another place. And hopefully within a year, we'll have 3 observatories operating, providing us with data that is being analyzed by machine learning software.
I have 2 questions that kind of stem out of your talk about the skeptics and stepping on the flowers. So one is, and I'll ask this one afterwards, but why do you think that scientists really do that? Is it all about arrogance and ego? Is it that you're going kind of maybe against their religion? Or is it something else entirely that, you're getting the spotlight, but they're not getting it? But before I ask that, I wanted to say, if there was someone in your shoes possibly listening to this, or who has this kind of anomalous evidence, who wants to take the same approach as you, but has seen you on Lex and Joe, seen the criticism, seen the ridicule that you've gotten, also seen the love and support that you've got, but, we kind of outweigh the negative to the positive sometimes, unfortunately. What advice would you give to this scientist who has all of this data, all of this evidence, is as excited as you, but just doesn't want to get into the public eye because they're scared for their life, they're scared for their family, scared for their reputation?
Well, I think the joy of doing science is being curious and not surrendering to these forces. I mean, obviously, people like Copernicus and Galileo suffered for just arguing that we are not at the center of the universe. But look at what we do with that knowledge now. We have spacecraft that can reach Mars. That would not be possible if we thought that Mars is circling the Earth, the way that the old model was. And so for the benefit of humanity, we need to pursue the evidence and release it. And so if there are people who hesitate, please contact me and we can work together. And I'm not afraid, because to me, the benefit to humanity in the long term by adapting to the reality that we live in will be far greater. I mean, it's always good to know the reality. It's never a disadvantage. You want to know the cosmic neighborhood that you live in. You want to know whether you have neighbors. Right now the universe is very lonely. We feel that we are alone, and if we find a partner out there, it will give a new meaning to our existence, and it will change world politics and everything. That's the way I see it. So the benefits are great, and it's really not about me or any other individual. It's about the future of humanity. It's the biggest question that we can ask as scientists, much more important than finding the nature of dark matter, for example. Now, coming back to your earlier question, I think the reason that there is a lot of pushback is twofold. First of all, there are experts, people that worked on rocks for decades, rocks from the solar system. And if you say that in the sky there could be something different, just because only over the past decade we discovered the first objects from outside the solar system. That's the Interstellar meteor in 2014 and Oumuamua in 2017. And some of them, those two look a bit strange. The meteor was moving faster than 95% of the stars near the sun, and it maintained its integrity down to the lower atmosphere. So it had material strength tougher than even iron meteorites. And so if you say, okay, well, maybe either this meteor or Oumuamua were artificial in origin, that should be explored. Of course, the experts instead, they want to argue, well, it's natural because that's what they base their stature on, and it creates a cognitive dissonance for them. It makes them upset just to imagine something so different from what they were used to in their career. And so when someone is confronted with an anomaly that is very troubling, that is different from what you are used to, it makes them upset. And I saw that because one of them came with me from a lecture about Oumuamua, and he said, Oumuamua is so weird, I wish it never existed. And that is a cognitive dissonance. Basically, it creates unrest. It makes you upset. You want to shove it under the carpet. And the way to do that is to say, it's a rock. It is a rock, but it's a rock of a type that I've never seen before. Case closed, put it under the carpet, let's move on. And that is not the way science should be done. You should say instead, well, it does look weird relative to the rocks that I'm familiar with. Let's get as much data as possible about similar objects in the future, and let's allow for it to be something completely different than a rock. We should allow that, because otherwise we would not seek additional evidence. We would say case closed, which is pretty much what those experts are trying to say. The second element is, when I submitted my paper for publication about Oumuamua potentially being pushed by reflecting sunlight and being artificial in origin, it was accepted for publication within 3 days. And people came to me and said, this is an interesting hypothesis, people from within the astronomy community. But then the paper got a lot of attention from the media. In fact, it was featured on Michael Smerconish on CNN. It's the first time I saw a quote from a paper in the Astrophysical Journal Letters appearing on a television screen in Smerconish, as if it's a political statement that he often puts up there. And so he put it out and said, what does it mean, and so forth. So as soon as my colleagues started noticing that I'm getting a lot of attention, and in fact, just a few days after the publication, I went to Berlin. There was a conference, The Falling Walls. As soon as I arrived there, I received invitations from Good Morning America on my email, and there were like several tens of reporters that wanted to speak with me over there. They put them in one room. And so as soon as my colleagues noticed that much attention, they started to get upset. I told my students in the class that I'm teaching at Harvard this semester, I said, I'm teaching a class on electromagnetism in astrophysics. And I said at the beginning, I said, what is the strongest force in academia? It's not gravity, it's not electromagnetism, it's jealousy.
Mm.
That's the strongest force in academia. So if you want to understand a response of this nature, you have to realize that it makes a lot of my colleagues upset that this gets attention. And to me, the attention is a reflection of the fact that the public cares about it. And the public pays taxes to fund science. So why can't we just address this subject in the scientific way within the mainstream, just like we address the question of what's most of the matter in the universe, dark matter? We don't know what it is. We pour billions of dollars into such research. We did that over the past few decades. We haven't found what the dark matter is, but we did not fund the search for technological objects near Earth by more than 1% of that amount, much less than that. And so I think it's about time for changing priorities. And my hope is that it will become part of the mainstream. And I can guarantee one thing, that if another object like Oumuamua is looked at and it becomes clear within a reasonable doubt by having a lot of data that it's actually not natural in origin. For example, we are able to get an image of it, and it does look like it's not a rock. Then the people who obtain that image will say, okay, this object indeed is technological. We are not alone. And in fact, Oumuamua, we don't know what it was. This is really the first time anyone discussed this possibility. And those that ridiculed what I said will basically forget about it and say that they said it all along. We thought about it first, and we said it. So by the way, I don't mind if that will be the reality, as long as we learn that we are not alone. As I said, that's the most important element here.
How can we make talking about aliens, extraterrestrials, more mainstream? It still feels like a taboo topic. And I also want to kind of layer on a question of, do you think that it can be a bipartisan bridge? Like bees, for example, saving the bees is possibly, I think Paul Stamets said, the number one bipartisan bridge. People, regardless of left or right, up or down, they love talking about saving the bees. We've all looked up at the stars, whether you're in a city, whether you're out in the countryside, whether you're in the city and you see a single star, the countryside, you see the entire belt, whether you're sober or inebriated. We've all had the question, had the conversation, are we alone? Is there life out there? Could there be life out there? How can we make this conversation more palatable to even religious folks? Younger children as well, get them thinking about this from 5 or 10 years of age, and use this question and conversation and field of inquiry as an on-ramp towards a more connected and a more curious civilization.
Yeah, I completely agree. This is a unifying subject, because there were hearings in the US Congress on unidentified anomalous phenomena. And especially a year ago, members of Congress from both sides of the aisle were asking questions, and were very curious. And this is the curiosity we have as children that gets suppressed when we become adults, and especially gets suppressed in academia when we become experts. Instead of showing off, instead of pretending to be the adults in the room, let's just collect evidence and figure it out. Okay, it's a fundamental question that will shape the future of humanity, could inspire us to do better, because we'll see someone doing better than us already. And because of the stakes are so high, let's invest money in collecting the evidence. When people say there is no extraordinary evidence, that's simply a reflection of the fact that we haven't really engaged in the search. We haven't invested the billions of dollars that you need in order to make progress. Finding the first galaxies in the universe with the Webb telescope cost $10 billion. Finding the Higgs boson with the Large Hadron Collider at CERN cost $10 billion. New knowledge doesn't fall into our lap. We have to work hard and put resources into it. And these sums of money are negligible compared to what we put in military budgets worldwide. We put $2.4 trillion a year. Just think about it. That's 240 times more every year than these big scientific projects. And so it's just a question of priorities. And I think we should definitely change our priorities. I know exactly what needs to be done and how we can collect much more data on possible technological signatures. And just having an opinion and arguing that the evidence is not sufficient is not a good way to make progress. We can remain ignorant forever because this is a self-fulfilling prophecy. When you tell yourself there is nothing to be learned, you're not seeking the evidence. And, just the fact that there are so many stars out there with planets like the Earth already should convince us that, we're probably not the pinnacle of creation. There must be many things like us already out there, and let's just find them. Why should that be controversial? Why should that be heresy? So I do hope for a much better future. That's the future I'm trying to bring about. And stay tuned. It may happen in the coming years because the one question that I'm still curious and don't know the answer to is whether the US government has relevant information because they monitor the sky much more than astronomers do. They have much bigger budget. And there will be, hopefully, a hearing in Congress in November 2024 after the elections. And hopefully we'll learn more. If the government has this data, I hope they will share it with scientists like myself because their day job is national security. My day job is to figure out what lies outside the solar system.
I mean, brilliantly put. So thank you for that. Looking forward to November 2024 for alien technology and nothing else. Dr. Loeb, this was a fantastic conversation. I have one more question for you. Gen Z and Gen Alpha, they're younger generations. They're very different generations than the baby boomers or the millennials. They're growing up in technology. I believe that their brains are wired very differently. For sure, they act very, very differently from, language and so forth using technology. You're looking for tech signatures. They are the signature technological generations. So what advice do you have for young Gen Z and Gen Alpha, whether they're in middle school or just about to graduate high school or just about to graduate post-secondary, who are looking to get into this type of work, who have been inspired by folks like you, who've watched Lex, watched Joe Rogan, and really want to help with this mission, want to see if humanity is the only civilization out there or if we are, one among the many dating app profiles in existence.
Right. Yeah. So, by the way, I often joke that if the aliens are intelligent, they will avoid us.
Why?
But
Why?
because we are not that attractive if you look at what happens around the world.
Sure.
So that brings me to my advice to Gen Z. I'm really hopeful. I think, as you say, there is hope for the future because the current generation is different than past generations. Because of technology, I'm much more hopeful. And my advice is, there is this tendency, including for members of Gen Z and to complain about the past. I mean, that's natural. The past had a lot of faults, that there is a lot to complain about. I'm also complaining about the present, not just the past. And so, you can spend your life complaining about the wrong things that were done in the past, but a much better way to live your life, because, we live for such a short time. Let's make the best of it. A much better way is to produce a better future. Okay. So forget about, the reason there are wars in the world is because people remember the past and want to somehow compensate for something they didn't like in the past by doing something even worse to the enemy. And so that is, you can waste your life just trying to hurt other people who did wrong in the past, but that's not a fulfilling way. So I think let's just forget about the past. Obviously, humans did a lot of wrong things. Let's just try to create a new future that is far better. How do we do that? Well, using science and technology. That's my answer, because science is better than politics. The reason it's better than politics is because politics is about zero-sum games where if someone benefits, another person loses. Okay, so there are limited resources. The message of science is very different. It's about collaboration, working together, and it's an infinite sum game, because if I gain new knowledge, suppose I find out that there are extraterrestrials, everyone benefits from it. So it's an infinite sum game. There is no limit to how much all of us can benefit. And so that offers the best prospects for the future. Now, add to that the use of artificial intelligence. I see that as a tool that we can shape to benefit us greatly, because all the boring jobs that our ancestors had to do, like including putting bricks to build the building, that can be done by robots now. And let's give all the boring jobs to AI, okay, so we can do the more exciting stuff of exploring the universe, figuring out things like, are we alone or not? That is my message to the young generation. It's so exciting to live at this time, because the future can be very different than the past. And I myself keep my childhood curiosity by forgetting about the past and just thinking about the future.
Dr. Loeb, thank you so much for this conversation. Where can we find you online and how can we follow your work?
So every day or two, I post an essay on medium.com. I have 50,000 followers, and I very much hope that this audience will increase. These are essays about science, about the future, about the search for extraterrestrials. You can find me at Avi Loeb at medium.com. And other than that, I have two recent books that came out, Extraterrestrial and Interstellar. There will be a Netflix documentary coming out, hopefully by the end of 2025. And of course, I have a website at Harvard University where you can find scientific papers that I publish, more than 1,000 of them.
Oh, wow. You're a very busy man. Thank you so much for taking the time to talk with me today. It was a great 100th episode, so thank you so much.
Thanks for having me.